January 17, 1943, the sky above the Ruhr Valley. The morning broke cold and crystalline over industrial Germany. At 22,000 feet, Oberleutnant Franz Stiegler banked his Messerschmitt Bf 109 into a climbing turn, scanning the horizon with the practiced vigilance of a man who had survived 2 years of aerial combat. The air at this altitude bit through his leather flight suit, thin and merciless. Below him, the patchwork farmlands of western Germany stretched toward the smoky haze of Essen's factories. Above, Contrail scratched white lines across an impossibly blue canvas. He had intercepted American bomber formations before, the lumbering fortresses with their bristling gun turrets, the predictable P-38 Lightnings with their twin-boom silhouettes. He knew their rhythms, their limitations, their breaking points. But on this frozen morning, something new wrote itself across the German pilot's understanding of warfare. Something that fell from the sun like a hammer thrown by an angry god. Stiegler never saw it coming. None of them did. The first indication was not visual but auditory. A sound like fabric tearing but magnified 1,000 times. A shrieking roar that seemed to split the atmosphere itself. Then the shape materialized, massive, impossibly fast, dropping nearly vertical through his altitude in a power dive that defied everything the Luftwaffe pilot had learned about aerodynamics and structural limits. The aircraft, broad-winged, radial-engined, painted in the dull olive and gray of American machines, plummeted past his Messerschmitt with such velocity that the turbulence flipped Stiegler's fighter onto its back. By the time he recovered, leveling his wings with hammering heart and white-knuckled hands, the American plane had already pulled out of its dive 3,000 feet below, climbing back toward him with energy that seemed inexhaustible, impossible, almost contemptuous in its casual display of power. The Republic P-47 Thunderbolt had arrived in European skies. For the German fighter pilots who had ruled the airways over France and the Low Countries since 1940, who had broken the back of the Royal Air Force over Britain and turned the Eastern Front into a killing field of Soviet aircraft. This moment represented something more than tactical surprise. It marked the beginning of a psychological unraveling, a fundamental challenge to assumptions that had sustained them through years of combat. They had been told, by their commanders, by their propaganda, by the evidence of their own victories, that German engineering represented the pinnacle of military aviation, that the Messerschmitt and Focke-Wulf fighters embodied technological superiority that mere industrial capacity could never overcome. They had been assured that American pilots were soft, undertrained, dependent on numerical advantage rather than skill. They had believed, because belief was necessary, that quality would always triumph over quantity. The Thunderbolt shattered these certainties. With the blunt force of 7 tons of aircraft, traveling at over 500 miles per hour in a near vertical, dived out the story of this aircraft, and the stunning impact it had on German fighter pilots who encountered it, begins not in the skies over Europe but in the cramped offices and drafting rooms of American aircraft manufacturers in 1940, when the war seemed distant and European, a problem that might never require American blood. Alexander Kartveli, the Georgian-born designer working for Republic Aviation, approached the challenge of creating a high-altitude escort fighter with an engineer's pragmatism rather than an aesthete's elegance. The Army Air Corps wanted range, altitude performance, and firepower. Kartveli gave them excess in every dimension. Where other designers sought to minimize weight and maximize agility, he built what critics mockingly called a flying bathtub, an aircraft so large and heavy that early skeptics doubted it could even achieve competitive performance. The prototype that emerged in 1941 weighed more than twice what the Messerschmitt Bf 109 weighed empty. Its radial engine, the massive Pratt & Whitney R2800 Double Wasp, displaced 2,800 cubic inches and generated 2,000 horsepower, more than any fighter engine then operational. The propeller measured over 12 feet in diameter. The fuselage, broad and deep to accommodate the massive engine and its turbocharger system, gave the aircraft a blunt, aggressive appearance that seemed to embody American industrial philosophy. If elegance requires compromise, then build something too powerful for elegance to matter. But it was in the dive that the Thunderbolt's true nature revealed itself. The same weight that made it sluggish in turning combat transformed into devastating advantage in vertical flight. Physics became weapon. Gravity became ally. The P-47 could enter a dive from high altitude and accelerate past 550 miles per hour, speeds at which German fighters began experiencing control surface flutter and structural failure. The Messerschmitt Bf-109's wings would literally begin tearing themselves apart above 470 miles per hour. The Focke-Wulf FW-190, generally more robust, started encountering compressibility effects and control reversal above 500. The Thunderbolt, with its thick wings and massive airframe, simply kept accelerating, kept diving, kept falling like a meteor wrapped in aluminum and fury. German pilots learned this truth in the most visceral way possible. Through surprise, through helplessness, through watching their tactical advantages evaporate in seconds. Lieutenant Hans Philipp, a Luftwaffe ace with over 200 victories, recorded his first encounter with the P-47 in his combat diary in April 1943. His formation had bounced a group of American bombers over the Dutch coast, executing the standard attacking pass from above and behind. The bombers' formation tightened, their defensive fire intensified, but this was familiar, manageable. Then Philipp's wingman shouted a warning over the radio. American fighters above, very high, perhaps 28,000 feet. Philipp's formation was at 24,000, still with altitude advantage over the bombers, and he made the calculation that had served him well for 3 years. The American escorts would have to dive to engage, surrendering their height, and in the energy-depleting climb back up, they would become vulnerable, targets for German fighters who knew how to preserve and manage energy in combat. But the Thunderbolts did not behave according to script. They rolled inverted and simply fell, not in the controlled dive of fighters sacrificing altitude for speed, but in a plummeting drop that seemed to accelerate beyond reason. Philipp had perhaps 3 seconds to react, to turn into the attack, to prepare his guns. The Thunderbolts flashed through his formation at a closure rate exceeding 700 miles per hour combined. One P-47 fired a burst so brief Philipp barely registered the tracers before the American was already a mile away, pulling out of the dive with energy to climb back to altitude. Another Messerschmitt in Philipp's formation simply exploded, not from bullet damage but from structural failure as the pilot attempted to match the American's dive speed, overstressed his airframe beyond its limits, and tore his own wings off in the desperate attempt to escape. Philipp broke off the attack. In his diary that evening he wrote, "We are no longer fighting pilots. We are fighting gravity itself, weaponized." This was not isolated experience. Across the combat zones of Western Europe throughout 1943 and 1944, German fighter pilots encountered the same tactical reality. The Thunderbolt could dictate engagement terms through sheer physical mass and power. If a P-47 pilot found himself at a disadvantage, outnumbered, low on ammunition, damaged, he simply pushed the nose down and dove. No German fighter could follow without risking structural failure, or at minimum, falling so far behind that the American would be gone before the German could pull out and reacquire visual contact. The Thunderbolt's ability to dive at speeds approaching the sound barrier gave its pilots an exit strategy that German fighters could not counter, an escape hatch that fundamentally altered the psychological balance of aerial combat. For German pilots, this reality was maddening in its implications. Air combat in the Second World War operated on principles of energy management. Altitude could be traded for speed, speed for position, position for firing opportunity. Skilled pilots learned to read these exchanges, to force opponents into energy-depleted states where they became vulnerable. But the Thunderbolt broke this equation. It had so much potential energy by virtue of its weight, and such strong structures to withstand the conversion of that energy into speed, that it could spend energy profligately, wastefully, knowing it could always recover through sheer power. The massive R-2800 engine gave it climb performance that, while not matching the lighter Messerschmitt Bf-109's best rate, could be sustained for far longer without overheating or mechanical failure. German pilots began reporting something unprecedented. Americans who fought badly, made tactical errors, allowed themselves to be maneuvered into disadvantageous positions, and then simply refused to accept the consequences. They would dive away, and there was nothing the German pilot could do except watch them go, watch them escape, watch them survive mistakes that should have been fatal. This was more than frustrating. It was demoralizing. It suggested that the war had moved beyond questions of skill and courage into realm of pure industrial might, where the side with heavier aircraft and more powerful engines could absorb tactical defeats without strategic consequence. Hauptmann Johannes Steinhoff, a decorated ace commanding a Jagdgeschwader in France, wrote to a friend in late 1943, "The Americans do not fight us so much as overwhelm us. Their pilots are often mediocre, but their machines are magnificent. A mediocre pilot in a Thunderbolt can survive against an expert in a 109 simply by refusing to fight on our terms. They choose when to engage and when to depart, and we must accept their choices." But the psychological impact went deeper than tactical frustration. The Thunderbolt's dive performance became symbol, a physical manifestation of the vast industrial disparity that increasingly defined the war. German pilots knew, even if they could not openly discuss it, that their factories were being bombed into rubble, that fuel supplies were dwindling, that replacement aircraft were arriving in smaller numbers with lower quality. And into this context came the Thunderbolt, an aircraft so heavy it seemed wasteful, so overpowered it seemed excessive, armed with 8 50 caliber machine guns when 4 would suffice, built with such robust construction that it could absorb battle damage that would destroy any German fighter. One Thunderbolt pilot returned to base with over 200 bullet holes in his aircraft. Another lost 6 cylinders on his radial engine, fully a third of the engine's capacity, and flew home on the remainder. This was the abundance that haunted German fighter pilots, the material reality that propaganda could not quite overcome. Each Thunderbolt represented approximately 300,000 man-hours of labor and $85,000 in 1943 dollars. Republic Aviation's factory in Farmingdale, New York, was producing them at a rate exceeding 300 per month by mid-1943. The Germans could not match this production. They could not even approach it. And every pilot who encountered the P-47 in combat understood, at some level beneath conscious thought, what this meant for the trajectory of the war. The sound of the Thunderbolt's dive became acoustic, signature of this disparity, the tearing shriek of an aircraft pushing through air at speeds near compressibility, the roar of 2,000 horses unleashed in full power, the thunder of 8 machine guns firing in unison. German pilots learned to recognize this sound, learned to fear it, learned that the seconds after hearing it represented their narrowest window for survival. Some developed involuntary flinch responses. Others reported difficulty sleeping, hearing the sound in their minds during rare hours of rest. Oberleutnant Walter Krupinski, who survived the war with over 190 aerial victories, later recalled, "You could be winning the fight, you could have the American in your sights, your finger tightening on the trigger, and then that sound. That terrible sound. You knew in that instant that his wingman was above you diving, and you had perhaps 2 seconds to break away before his bullets found you. Sometimes you broke too late. Sometimes the sound was the last thing pilots heard. Yet the Thunderbolt was not invincible. In slow-speed maneuvering combat, particularly below 15,000 feet, the lighter German fighters retained advantages in turn radius and sustained turn rate. A skilled German pilot who caught a Thunderbolt at low altitude, low speed, without altitude to dive into, could exploit the American aircraft's poor roll rate and heavy controls. But these scenarios became increasingly rare as American fighter pilots learned their aircraft strengths and adapted their tactics accordingly. The official 8th Air Force tactical doctrine evolved to emphasize altitude advantage, fighting in pairs, and ruthless exploitation of the P-47's dive capability. American pilots were instructed, never turn with a 109 or 190 unless you have overwhelming positional advantage. Instead, use boom and zoom tactics, dive on the enemy, make one pass and either climb back to altitude if you have energy or dive away if you don't. Never stay slow at low altitude. This tactical discipline, combined with the Thunderbolt's physical advantages, created a combination that German pilots found increasingly difficult to counter. By late 1944, experienced Luftwaffe pilots were being killed or captured at rates that training could not replace. The new pilots arriving at the front had perhaps 150 hours of flight time, compared to 400 hours for their predecessors in 1941. They lacked the situational awareness to avoid the Thunderbolt's attacks, the energy management skills to exploit its weaknesses, the experience to survive first contact, and the Thunderbolts kept coming. more of them every month. With better trained pilots, with more fuel capacity as drop tanks improved, with evolving tactics that maximize their advantages, the symbolism was not lost on German military leadership. In intercepted communications and captured documents, Luftwaffe commanders referenced the Thunderbolt as evidence of American productive capacity that Germany could not match. Albert Speer, the Reich's armaments minister, noted in his memoirs that reports of American fighter performance contributed to his private pessimism about German prospects. The Thunderbolt was not just defeating German fighters in combat, it was defeating German morale through its mere existence, through what it represented about the relative strength of the combatants. And still, the aircraft evolved. Later variants incorporated paddle blade propellers that improved climb rate. Water injection systems boosted engine power for short periods to 2,300 horsepower. Improved turbocharger systems maintained performance at altitudes above 30,000 feet, where the air was so thin that early war German fighters could barely function. By 1945, the P-47N model featured a combat radius of 1,000 miles, allowing it to escort bombers deep into Germany and still have fuel for extended combat. This aircraft, this flying bathtub that critics had once dismissed as too heavy and ungainly, had become the most produced American fighter of the war, with over 15,000 examples built. For the German pilots who survived the war, the memory of the Thunderbolt's dive remained vivid decades later. In post-war interviews and memoirs, they returned again and again to that moment of recognition, that instant when they understood they were facing not just a new aircraft, but a new category of military power. Some described it in technical terms: the differential in dive speeds, the superior roll rate at high speeds, the seemingly limitless ammunition supply. Others spoke more abstractly, referencing the psychological weight of knowing that every engagement could bring that sound, that shriek, that plummeting mass falling toward them with the inevitability of an avalanche. The Thunderbolt's impact extended beyond its direct combat record. It freed Allied bombers to strike deeper into German territory with acceptable loss rates, enabling the strategic bombing campaign that devastated German industrial capacity. It allowed American fighter pilots to develop aggressive offensive tactics rather than purely defensive escort formations. It forced the Luftwaffe to divert resources to developing counters, higher performance variants of existing fighters, jet aircraft programs that consumed enormous resources, rather than focusing on operational effectiveness. In this sense, the P-47 won battles not just through the kills it scored, but through the responses it demanded from an enemy already stretched beyond sustainability. There is a photograph, taken in May 1945, of a long line of Republic P-47 Thunderbolts parked at a captured German airfield. The aircraft stretch into the distance, dozens of them, perhaps hundreds, their propellers still, their guns silent. In the foreground, a German Messerschmitt Bf 109 sits abandoned, its paint faded, its canopy cracked, its landing gear collapsed. The image captures something essential about the conclusion of the air war over Europe. Not simply that one side won and the other lost, but that victory came through the wedding of industrial capacity to tactical innovation, through the transformation of assembly line output into strategic advantage. The German pilots who first encountered the Thunderbolt's meteor-like dive in those cold skies of 1943 witnessed the future arriving at terminal velocity. They saw in those plummeting shapes falling from the sun the physical embodiment of a nation that could afford to build fighters weighing 7 tons, that could power them with engines producing 2,000 horsepower, that could train pilots to fly them and mechanics to maintain them, and factories to replace them faster than combat could destroy them. They saw, though they might not have articulated it in these terms, the material foundation of what would later be called the American century, the transformation of industrial might into military dominance, the conversion of productive capacity into strategic advantage. The shriek of the Thunderbolt's dive became the sound of this transformation, an acoustic signature of abundance weaponized, of resources so vast they could be poured into a single aircraft type until perfection became possible, not through elegant engineering, but through overwhelming force applied precisely. It was democracy's answer to totalitarianism, not a superior philosophy of combat or a more efficient military hierarchy, but simply more More steel, more fuel, more engines, more bullets. More training, more pilots, more aircraft, more of everything, delivered with such relentless consistency that skill and courage, while still valuable, became insufficient to change the outcome. In his post-war memoirs, General Lieutenant Adolf Galland, who commanded the Luftwaffe fighter forces, reflected on the moment when he first saw a full squadron of Thunderbolts executing coordinated boom and zoom attacks against his formation. He described watching them dive, attack, climb, separate, reform at altitude, and repeat, an efficient mechanical process that consumed his fighters through attrition. "I understood then," he wrote, "that we were not fighting an air force. We were fighting an industrial system that manufactured air forces, and the difference was not one of degree but of kind. This was the lesson of the Thunderbolts dive, that war between industrial powers is ultimately won not on battlefields alone, but in factories, in training centers, in the vast machinery of production that can sustain losses and generate replacements faster than the enemy can inflict attrition." The German fighter pilots who watched those American aircraft plummet past them at impossible speeds were witnessing not just tactical innovation, but strategic inevitability. The moment when superior resources, properly deployed, overwhelmed superior skill, and yet, in the individual encounters, in the specific moments when specific pilots faced specific challenges, the human element persisted. There were Thunderbolt pilots who panicked, who dove when they should have fought, who wasted their aircraft's advantages through poor judgment. There were German pilots who found ways to exploit the P-47's weaknesses, who scored kills against superior numbers, who survived through wit and courage when physics suggested they should have died. The war was never simply machines fighting machines, never purely about statistics and production numbers, but in the aggregate, over thousands of sorties and tens of thousands of combat engagements, the pattern held. The Thunderbolt dove, the German fighter could not follow, and slowly, inexorably, the balance of aerial power shifted. By spring 1944, the Luftwaffe had effectively lost air superiority over Western Europe. By summer, German fighter pilots were being assigned to ground attack missions because there were no longer enough Allied bombers to intercept. The escort fighters had made bomber operations sustainable at acceptable loss rates. By autumn, newly trained German pilots were dying on their first or second combat missions, unable to survive contact with enemy forces that outnumbered them, outperformed them, and had learned to fight in ways that maximized their advantages. The Thunderbolts dive represented all of this: the tactical, the strategic, the industrial, the psychological. It was physics and economics welded together, gravity harnessed to ideology, weight transformed into weapon. The German pilots who encountered it understood, even when they could not admit it openly, that they were facing something unprecedented, an opponent with margins of error so wide that individual excellence could no longer guarantee survival, let alone victory. In the silence after war's end, in the accounting of victories and losses and the long tallying of costs, the Thunderbolt's contribution can be measured in statistics. Over 3,700 aerial victories credited to P-47 pilots, over 9,000 locomotives destroyed in ground attack missions, over 86,000 sorties flown. But its deeper impact, the psychological weight it placed on German pilots, the way it symbolized industrial disparity, the acoustic memory of its dive shriek in the minds of those who heard it and survived, these effects resist quantification. What remains is the image: a 7-ton fighter rolled inverted at 28,000 feet, nose dropping toward vertical, pilot feeding in power as gravity takes hold, the aircraft accelerating past 500 miles per hour, wind screaming over the wings, control surfaces stiffening as air compresses, and below a German pilot recognizing the sound, understanding in that instant that his tactical advantage has evaporated, that his only choice is to break away or die, that the machine falling toward him represents something larger than itself, represents a nation's industrial will made manifest, represents the transformation of abundance into advantage, represents the future arriving at the speed of a meteor. This was the truth the German pilots learned in those cold skies above Europe, learned through experience more visceral than any briefing could convey. That wars between industrial powers are won by those who can most efficiently convert their productive capacity into military force, and that no amount of tactical skill or operational excellence can overcome a sufficiently large disparity in resources. The Thunderbolt dove and in diving taught this lesson again and again, until the lesson became the inescapable reality that defined the war's conclusion. And in the end, when the guns fell silent and the aircraft were parked and the pilots returned to whatever remained of normal life, the sound lingered, that terrible, magnificent shriek of 7 tons of American aluminum falling like judgment from heaven, falling like proof of what abundance and democracy together could accomplish when challenged, falling like the future itself, unstoppable and inevitable as gravity,